Q34 Electrical and Electronics Engineering GATE 2017 Set 1. The load shown in the figure is supplied by a 400 volt line-to-line voltage and a three-phase source which has a sequence of RYB. The load is balanced and inductive, drawing 3464 volt amperes. When the switch S is in position N, the three wattmeters W1, W2 and W3 read 577.35 watt each. If the switch is moved to position Y, the readings of the wattmeter in watts will be dash. For a detailed lecture on the concept of three-phase power measurement, please refer the NPTEL video, Lecture 31, Connection of Electrometers, Wattmeter and Three-Phase Supply, a course on electrical measurements and electronic instruments by Professor Abhishek Chatterjee, Department of Electrical Engineering, IIT Kharagpur. Let's first have a look at the basic formula required to solve this problem. The total active power consumed in a three-phase balanced network is given by 3 times the phase voltage times the current times the power factor cos phi, where phi is the angle between the voltage and the current. If it is a star-connected network, then the phase voltage will be the line-to-line voltage divided by √3. On the other hand, if it is a delta-connected load, then the phase voltage and line voltage will be the same. Let's see the vector diagram of the power that is consumed by the load. Let us consider that the sequence is RYB. In a RYB sequence, this is the voltage between the red line and the neutral line. Then comes the Y phase. Then comes the B phase. This is VBN and this is VYN. Now since this is an inductive load, the current lags behind. Therefore, the current that is through the red phase lags by a power factor of phi with the voltage VRN. Similar is the case for VBN. IB lags behind an angle of phi, and similar is the case for IY. This angle is also phi. The angle between VRN, VBN and VYN is 120 degrees each, which is 360 degrees divided by 3. So the angle between these is 120 degrees. We need to know this basic information in order to find out the power factor that is involved. Let's solve this problem now. In the question, it is given that the line voltage that is supplied to the load is 400 volt and the phase sequence is RYB. The load draws a power of 3464 volt ampere. This is reactive power and hence the unit is given as volt ampere. When the switch is connected to the neutral line, then it follows a star network because all three R, Y and B phases terminate to this neutral line in a star fashion. So, under this condition, the active power that is drawn by each of the loads is given as 577.35 watt, which is by one phase. Therefore, the total active power is equal to 3 into 577.35, which is equal to 1732 watt. This happens when the switch is connected to the position N. Now the question is, when the switch is thrown to position Y, what will be the wattmeter readings W1, W2 and W3? This is the question. Just from the question, we can infer that W2 is equal to 0 watt because when this switch is connected to W, then all three phases R, Y, B will be terminated to the Y phase. Therefore, the voltage between these 2 points is 0 volt and hence W2 will read 0 watt. Now, we have to find out the value of W1 and W3. The wattmeter reading W1 will be the voltage between the phases VR and Y times the current through R phase times cosine of the angle between these two phases. Let's denote that as phi RY. And similarly, wattmeter reading W3 is equal to the voltage that exists between the B phase and the Y phase times the current that flows through the B phase times cosine of the angle between these two. I am denoting it as VBY. Now we have to find out the power factor and the product of phasal voltage and the phasal current. The power factor will be 577.35 divided by 3464 divided by 3. This is equal to 0.5. So this implies that the load angle is equal to 60 degrees. Now let's find out the product of phase voltage and the phase current. This is the power that is consumed by one phase of the load. This is equal to 3464 divided by 3, which is equal to 1154.6 volt ampere. We need to find out the angle between the voltage VRY and IR, and similarly we need to find out the angle between these two. Now for that we need to get a better idea of the vector diagram. The phase sequence mentioned is RYB, therefore the R phase leads the Y phase and the Y phase leads the blue phase. The angle between each of the phases is 120 degrees. We have to plot the voltages VRY and VBY, and also we need to find out the angle between this voltage and the respective currents IR and IB respectively. So first we'll plot this voltage and this current and find out the angle between these quantities. VRY is equal to the phase voltage of R minus the phase voltage of Y. Similarly, VBY will be the phase voltage of B minus the phase voltage of Y. This is the negative of VB, which is minus VBN, and this is the negative of the phase voltage VR, which is minus VRN, and this is the negative of the phase voltage minus VYN. VRY lies between this voltage and this voltage. Therefore, this kind of bisects both of them, and similarly VBY exists between this and this. This line is VBY line. We know that the angle between two phases is 120 degrees. Therefore, the angle between negative of Y phase and R phase is 60 degrees, and hence the angle between VRY and VRN is 30 degrees. Similarly, the angle between VBN and VYY is 30 degrees. Now let's draw the current vector. Since the load is inductive, the current lags behind the voltage by an angle of 60 degrees. So behind VBN, IB lags behind 60 degrees. Therefore, phi RY will be the angle between VRY and IR, which is 30 plus 60. This is 90 degrees, and the angle phi BY is equal to 60 degrees minus 30 degrees. This is equal to 30 degrees. Using this, let's find out the wattmeter readings W1 and W3. The wattmeter reading W1 is equal to VRY times IR times cos 90 degrees. Cos 90 is 0, therefore the wattmeter reading W1 is also 0 watt. Now let's find out the wattmeter reading W3. W3 is equal to VBY into IB into the cosine of the angle between these two, which is 30 degree. This is equal to root 3 into the phase voltage times the phase current times cos 30. This will be root 3 into 3464 divided by 3 into cos 30 is root 3 divided by 2. Root 3 into root 3 is 3, so this will cancel. 3464 divided by 2 is 1732 watt. This is wattmeter reading W3. There is another way to approach this. First, we inferred that the wattmeter reading W2 is 0 watt because the voltage of the Y phase is 0 once the switch is in Y position. Then we inferred that W1 is also 0 watt. Hence, the total active power flows only through the B phase. Therefore, the total active power, which is 3 into 577.35, will flow entirely through the B phase only. Therefore, wattmeter W3 will read 1732 watt. So the answer is option D. Thank you.